All right, good day to everyone. I'm just testing out my audio again. If you can hear me, just leave me a message in the chat. If you can hear me, respond in the chat, please. Okay, great. So good morning to everyone. We're about 1 or 2 minutes away from our start time. Um, I hope that everybody is doing well. I'm going to wait until a few more students are available. Yeah, I only see 4 students here right now. I'm growing. During the course of the class, if the stream ends up going down, I will restart, and all you'll have to do is just use the same link to log back into the meeting. So if anything happens and our stream gets disconnected, I will restart and you will just join the meeting using the same link. I see Alphonsus is back in. Okay, but okay, I'll give about 5 minutes or so, or either 5 minutes, or I will wait as soon as the majority of persons are here. As soon as I have 10 or 12 persons, I will start the class. In the meantime, I want to remind you of our class rules. I want to remind you about managing your video and audio to maintain the quality of our recording, as well as to maintain available bandwidth. I may not switch to video much today, but I will be using visuals as we go through the class. I hope that everybody is safe and in good health, and that you are doing the prescribed things to ensure that you do not contract the virus wherever you are. In most of our countries, most of our islands, we are in some form of lockdown, either partial or total. In my case, we are on the total lockdown until the 8th. Things start to resume. Well, not back to normal, but a partial lockdown would resume by the 8th, because here we have community spread has been identified here. So the measures are a bit more stringent to prevent the spread of this disease. Okay, I have 10 students, 9, waiting for one more student, and then we are going to start. I'm not sure if Mr. Daniel, I know this is here, I'm not sure if he wants to say anything before we start the class, but if he does, if you do, now is the time to do so.
Yeah, well, morning to everyone, and I trust we're staying free, COVID-19 that is. And again, every time I view it, it's like a blessing in disguise for us. Everybody should be in, so let's maximize. Let's make the best of it. I've been looking at the last few mats that a few of us posted. I haven't seen much more than the 3, so that you would get your marks by the end of the day. I started some corrections last night, got distracted. But I'm here and I plan to participate fully with you. I may ask permission or maybe on the chat. I'll use the chat a lot if I want to add anything to what Alvin may say.
Feel free.
So I'm here. I'm here. So when you're ready. Okay. Thank you again.
Okay, great. Thank you, Alphonsus. I want to say a few things before we get into content for today. The video from our previous class will be uploaded soon. The video, however, if you remember, we had about 1 or 2 breakdowns in the class in terms of connectivity. And so the video would be 2 things. The video would be incomplete because there are certain sections that were not recorded because of technical reasons, and it might be a piece here, a piece there, because of what transpired on the back end in terms of technical stuff last class. But I will be posting it by the end of today. It should be up. All right, so let's look at what we are going to do this morning. For this week, you had a collection of videos that you were supposed to look at. The videos were posted as well. Some were presentations, but they're essentially videos. They were posted on the Kawasa online site. And we looked at mainly installation, some safety, a little bit of disinfection, and something we call SCADA. Okay, so today what I'm going to do within the time allotted, I am going to attempt to summarize some of the more important items from this presentation. I am going to start with safety. And I'm starting with safety because I think it's an area that is usually, sometimes we forget how important it is, and we go along our way until something bad happens and we realize we should have done this or we should have done that. So I want to just start with safety to point out how important it is, because no matter how certified you are or how much information you have, if you are dead, you are useless. If you're dead, you can't do anything for the utility. You can't do anything for your family. You cannot do anything for your country. Okay, and I say useless in that sense. Okay, so you got to gather all the knowledge and have all the skills, and if you're not being safe on the job, it means you're risking your life, and losing your life on the job is not an option. So we want to make sure that we are safe. So, but before I go into there, so this is what we will be looking at today. This is what I want, the 3 areas I will be highlighting: safety, pipe installation, and disinfection. And towards the end, I will speak a little about SCADA. Okay, so these are the 3 areas we want to highlight today. But I'm starting with safety. And when we are on the job, the requirements for safety of employees and so on the job, individuals on the job, is set by an organization named OSHA, Occupational Health and Safety Administration. And OSHA looks at all areas of health and safety in a job place. And they set regulations for what has to happen. Now, when it comes to water distribution, there are quite a few areas where operators can be in hazardous conditions or deal with hazardous chemicals, and these things have an impact on your health. Okay, so while it's important for you to be able to do your job on time, as efficient as possible, it is also important for you to be healthy and safe. So in terms of, I want to point this out. This here is mentioned in one of the videos, and it's a term that will come back again and again as you go through different items in water distribution. Usually, whether it be a confined space, a trench, or any other area that presents hazards, usually an inspection by a competent person is required. And when we say a competent person, all we just mean two things. This person should be able to identify hazards, and they should have the authority to take quick actions to eliminate the hazards. Okay? And it's important that they have the authority, because if, for instance, I'm a safety officer at a water utility, and I can identify hazards, but my hands are tied, there's nothing I can do. I cannot say, okay, this is a hazardous condition. This trench, for instance, which is one thing we'll be looking at today, this trench is susceptible to cave in. So I cannot say, okay, workers, you'll have to come out of the trench. We're going to stop work and let's sort out this hazard before work continues. Okay? Because if I don't have the authority, I can't tell anybody what to do. Okay? So the competent person must both have the skill set or the ability to identify the hazards and have the authority to do something about it. If that person cannot do something about it, they don't have the authority, then we don't consider them a competent person in that sense. The OSHA requires that this is the person who's doing the inspection. Okay? Now, in terms of trenches, okay, which is something that was looked at in the course material about as one of the things that has to be done when you are installing pipe. Okay, a trench is dug, and sometimes machinery is used to do the entire thing, but inevitably you might have human workers who end up in the trench at some point in time. Okay, so if you look at the video, you will learn that quite a few people die every year from work-related hazards. And in the US, quite a large number, I think it was either 80 or 40 persons die every year from cave-ins in trenches. So it's important, even in St. Lucia, there's a couple years back when some utility workers, I can remember at least one death from a cave-in in St. Lucia. That was somewhere on Jeremy Street, somewhere by the marketplace, where the workers had dug a trench. They were doing some repairs or installation, and there was a cave-in, and one of the gentlemen involved passed away. So we want to prevent that. So OSHA requires that if the trench is less than 5 feet deep or the walls are made of stable rock, then it says we don't need any support. However, if they're greater than 5 feet or the walls are made out of type A, type B, or type C soil, then we require some kind of support, and we will look at the kinds of support. The video also did a very good job of discussing this, but I want to point that out. So this is what you need to remember this. You need to remember that if our trench is less than 5 feet or is made of, the walls are made of solid rock, then we do not need support. But if the reverse is true, where it is greater than 5 feet or made of type A, B, or C soil, then support is needed. Now, the competent person should have the knowledge to tell, one, what type of soil we're dealing with. Now, in some instances, you're dealing with more than one type of soil. Because if you've ever been at an excavation, or if you ever did an excavation even on your property, as let's say you have a piece of equipment digging, as you dig deeper, you realize the consistency of the soil changes. And say you're digging a foundation for a house. As you dig deeper, most times you dig the foundation until you get to a quality of soil that is almost like rocky. You want to get to the rock so that when you put the foundation in, it connects to that solid thing, and you have a more solid foundation for your house or building or whatever you're trying to construct. Okay, so even when we are doing trenches, based on the depth of the trench, you may encounter various types of soil, and a competent person will suggest what type of support needs to be used for the type of soil that is in place. Now, your video went through a diagram like this, where it detailed the 4 different types of soil: stable rock, type A, type B, type C. And you can see that as we move from C to stable rock, we have increasing stability. Okay, so type C is the least stable rock and is the least stable soil, sorry, and stable rock is the most stable type of soil that we can have. Well, it's rock, not really soil, but you understand what I'm saying. Okay, so it's important to remember this. Okay, so if it's stable rock, then we don't necessarily need, if our wall is all stable rock and the competent person has looked at it, inspected it, and has come to a conclusion that there is not a likelihood of a cave-in, then we have no support. Okay, so we look further. These are some of the types of support that we can have. We can have sloping, benching, shoring, shielding. Now, the content goes through sloping, shoring, and shielding, but I didn't spend much time on benching. The idea of benching is that you take a kind of what we call a tiered approach. I want you to think of the seats in a stadium. If you look at the seats from the side, they look like steps. So when we do benching, we cut the trench so that the walls kind of step down towards where we actually doing work. And that will actually prevent cave-ins from happening. Now, this is a technique not only using trenching. If you're a student of agriculture and you look at how things are planted on a slope, very often benching is what's used, where you have flat areas, then a vertical, flat area, vertical. So you cut the thing into terraces, kind of. So very often that is used to prevent, to ensure that you have areas you could plant and stuff does not erode down to the bottom of the hill or wherever you're planting. So it's the same concept that we're using for trenches. In terms of benching as well, sometimes benching is also used for road construction, where you cut a road into some kind of hill. And I've seen some examples of it locally, but you may see some examples wherever you are, where you have this step-like approach to the slopes on the side of the road, and it prevents, again, cave-ins, it prevents erosion of material down onto the road. So it's a very stable way, it's a very good way of stabilizing the slope. Okay? But sloping and benching, they are similar in that both are methods used to stabilize, and both of them, they do not use any additional pieces of equipment. Whereas shoring and shielding rely on additional structural pieces of equipment to support the walls of the trench. Okay, so here is, so in the video discusses specifics about specific soil types. Okay, it gives you the angle at which the soil should be sloped for the various soil types. So here they for stable vertical walls, we can cut them at 90 degrees. Okay, providing that we are not we watch the way that we are digging and we maintain the 90-degree wall. Because you could have the top cut at 90 degrees and then you start to dig underneath the wall. That could cause a cave-in. Okay, so for stable rock, 90 degrees. Type A soil, 53 degrees. Type B soil, 45 degrees. And type C, 34 degrees. Now you will notice in the diagram, there's a little triangle there. Sorry, I went. Okay. You will notice there's a little triangle in the lower right-hand corner. And we are talking about degrees here. Okay. So the angle we're looking at for the slope, we're looking at the angle that is to the left of the triangle. Okay, so that's the angle that we are talking about here. So that angle here. Okay, and it's also given in other means. Now, this rule that we have here, sloping the sides of an excavation to an angle not steeper than 1.5 to 1 for every foot of depth, the trench must be excavated back for 1.5 feet. A slope of this gradation is safe for any type of soil. Now, if you would follow the video, this specification that's given here is the specification for soil type C. Soil type C, you're not seeing the slide? If you can see the slide, give me a thumbs up or yes. Yes, figure 1. There's a triangle to the right. This is what I was referring to. Okay, great. Wonderful. Okay. So this rule here is what will give us the utmost protection from cave-ins, for sloping, that is. Okay. Because this angle that we're looking at here, this is the 34-degree angle. This will actually provide safety for the least stable soil, which is soil type C. So if we are catering for the least stable soil, it means all of the soils that are more stable will be sorted out. So this, you could consider this to be an ultimate thing to do in terms of sloping. So if you're not sure what soil type is present, or if you have a situation where you have mixed soils, this may be a good option to prevent cave-ins. So you just go to the maximum protection that you can get. I mean, you have nothing to lose from going there, because at the end of the day, you want everybody to be safe. Okay? You want everybody to be safe. All right, there's one thing I did not notice in the video in terms of safety in trenches, but it was shown in the video, but not much was said about it. That is the presence of a ladder or some way of getting out of the trench, and it should always be there. Okay? It should extend a certain distance above the, I think it's 18 inches, is it? Above the top of the trench. Okay? So a ladder or some means of getting out of the trench should be available, and it should be close by. It should be close enough so that if there is an issue, persons can get out quickly. Now, the issue may not just be cave-in. The issue might be that two of you are working down in the trench and one man collapses because he has some kind of medical condition, okay? We should not have to think of how we're getting out of the trench if that happens. So the means should have already been put in place. Okay, so we're not just looking at cave-ins, that kind of safety in terms of your exits, how you're going to exit the trench. That kind of safety looks at more than just cave-in, because you could have medical conditions that can occur while you're in the trench, and you may need to get that person to receive some kind of medical attention. So it's always important. And there are also things like another scenario. There are places where you have things like flash flooding. Imagine a flash flood takes place and you're down in a trench. So these are some additional things that we have to consider when we're thinking about safety in a trench. I know I don't have that on the slide, but I just wanted to mention it. Okay, so here's an example of the trench shields. I'm not going to go through endless pictures and examples of these, because I think that the video does a pretty good job of discussing the different types of support for trenches. So if you did not look at the video, I encourage you to go back and go through the material. It was placed there so that you can acquire that knowledge. Okay, so I'm going to move on. Look at safety for disinfection, because in the process of pipe installation or repair, we have to do some disinfection. And if you look at the content, it mentioned two different types of chlorine that we would use. It mentioned the solid form of chlorine, and it also mentioned chlorine solution. Okay, thanks, Alphonsus. That's a good digging boxes. Yeah, that's a good addition. Okay. So when you're handling the various forms of chlorine, chlorine by nature is corrosive. Some forms are more corrosive than others, but it is not something that you want to have your hand in at any length of time. So usually we suggest that you wear some kind of personal protective equipment, PPEs. And you've been hearing a lot of that throughout the news media with what's going on with COVID-19. We speak about doctors and nurses, the frontline people needing PPEs, and there's what's going on in the US with the federal government and the state government and so on. Okay, so it's something that you should have heard over the past couple of weeks, but it's basically things that we use to protect our person, things like goggles, face shields, respirators, both the simple masks that are worn as well as those that actually, there's some that have big cartridges in them and they can filter out any toxic thing from the air so that what you end up breathing in is good. There are also other types of respiratory things where they actually provide a source of oxygen, so you don't have to breathe the air that is in your surrounding. Okay, but these are for more extreme scenarios. But for the chlorine, you should wear at least gloves, eye protection, and appropriate shoes and clothing. Okay? Most times, water distributors, when you're out in the field, most persons would have a steel toe boots that would protect your feet, and it would, most of them are waterproof, so water would not get, in some instances, workers are wearing actual rubber boots. If you work in very waterlogged conditions, some of you would wear actual rubber boots. Then you'd have some gloves on your hand, and you may have to wear goggles, not just because of the chlorine, but maybe the process of digging requires you to protect your eye. One of the things I noticed though in the Caribbean, and it seems to be widespread, is that many persons who actually work in situations where they require protective equipment do not wear it when they need to. I recall the instance of the waste treatment workers. I recall an instance a couple years back where the workers were provided with personal protection equipment such as gloves, and they would not wear the gloves. They would use their bare hands in whatever they were doing in terms of waste treatment and sewer. They would put their hand in the liquid and all that kind of stuff. And their complaint was that they were not used to working with the gloves. But it's better to be safe with protective gear. The first couple times that you use it, you may not be used to it, but it's better to be safe. And in actually using it, you will get used to working like that. But you have to protect yourself. Okay? You have to look out for your health. Okay, so I'll move to the next slide. Pipe installation. Okay, now quite a bit was done on pipe installation. What I did here, I just grabbed some screenshots from some of the videos just to highlight some of the things that you need to know. Okay, so okay, this is a bit ahead. I will pull up, I'll leave the PowerPoint. Okay, and I will pull up right. Okay, not open yet, waiting. Okay. So this is the presentation. You can find this in the downloadable resources section of the site. Some of you may have downloaded it already, but this is the instruction on pipe installation. And I just want to just quickly go through it. Okay, it tells now there's an error in the video in terms of the audio. I think when it starts talking about excavation, I think another term was used, and I think it's an error. I don't think it was the appropriate term. Okay, the term should be excavation. Okay, so installation has basically three main areas that we consider. Somebody has a question?
Avi. Good morning. Good morning.
I'm hearing somebody talking. Karancha, do you have a question? Yeah, I'll assume that that was an error. Okay, so we have three different things that we want to do for installation: transporting, excavation, pipe laying. For transporting, there are several considerations that we take. What's the size of the pipe? We need to decide, for instance, how we're going to transport the pipe, and how we transport it will be based on the size and weight of the pipe, the distance that we are from the job site. Okay, and the point was made that most times we use trucks because we are small. Most of us are smaller islands, so we use trucks to truck the pipes from one point to another. In terms of larger places like the US, they would have railway or trains that could transport the pipe. And we're looking at transporting over longer distances. And in some instances, they may use ships to transport the pipe. Okay. So transporting for us would be trucking, basically. Pipe handling is something that comes under transporting. And in pipe handling, we want to do inspection, we want to unload, stacking, stringing. Okay. The inspection is particularly important because we are spending money to excavate and to install the pipe. We want to make sure that the pipe we put down in the soil or wherever we're installing it, we want to ensure that that pipe is in good condition. So we want to inspect the outside of the pipe as well as the inside of the pipe. In some instances, based on the type of pipe, these pipes have special coatings on the inside, and we want to make sure that these coatings are intact so that we do not negatively affect either our flow of the water or the quality of the water. So we don't want to affect either of these things. All right. So the pipes must be inspected, and we inspect the pipes several times. We inspect it before we put it on our truck. We inspect it when we reach at the site. We inspect it after we put it down. So, because things can happen between the first inspection and the time that the pipe gets on the where we string the pipe or stack it. Things can happen between these different events, and we want to make sure that before we lay the pipe in the trench, the pipe is in good condition. Because if after we go through all of this, we lay the pipe and say a pipe had a big crack somewhere on it, and then finished, we've already finished laying it out in the trench, and then we come to do our testing of the pipe. While we're doing our testing of the pipe, we realize, boy, one of these pipes had a big crack, and so we have a leak. It means we have to do everything in reverse now, which costs us time, which costs us resources, which costs us money. Okay, so this is why we are doing that. Two, unloading, basically when we get to the site, so we would have to load and unload. We'd have to put the pipes onto the truck, and when we get to the site, we want to remove them. Depending on the nature or the size of the project that we're working on and the nature of the installation, the pipes can be pretty large. And in instances where the pipes get to a certain diameter, it's not really practical to try to have men offloading and loading these. So we use some piece of equipment, a crane, or sometimes the same backhoe that we use to dig, we might use it. Excavator, sorry, the same excavator that we use to dig, we might use, or backhoe, we might use it to offload the pipes from the truck. Okay. Stacking, when we talk about stacking, we're just referring to just putting the pipes kind of on top of each other. Now, there are certain things we have to consider there. Based on the pipe material, we may only be able to stack it up to a certain height. So we have to consider that, because the higher we go, the more pressure is on the pipes at the bottom of the stack. Okay, so that's one consideration. Two, we have to consider, we have to look for a flat area where you could stack and the pipes would be stable. And we have to look for an area where the pipes are not, we want to minimize contamination. In some utilities, the way pipes are being stored, I'm just jumping there because I've seen it. The way pipes are being stored is not acceptable. The pipes, a lot of times, sometimes the pipes are in a place where soil gets inside of them, rats and other types of pests get inside of them. And we want to try to avoid that, because we are using the pipe to transport drinking water. And yes, we will disinfect the pipe. Either during installation, we'll disinfect, but we want to minimize the amount of disinfection we have to do. We want to minimize the amount of contamination so that we ensure that whatever disinfection we do is effective. Okay. Now, based on what I'm seeing, I suspect this session is going to drop, but I'm not sure. But it looks like it may drop. So if it drops, I will